Hello, my name is Taylor Sisson. Today we're going to be doing a tutorial that is the first of hopefully a set of tutorials on how to use the program called Arena. This is a program by Rockwell Automation. You may want to go check them out. They seem like a pretty decent company, and they seem to have a lot of things that are really applicable to engineering and really a lot of different fields. Okay, so Arena, as you probably know, considering you probably looked up this video, is a software used to do simulations on a computer. So for this video, I'm going to assume that you know a few things. First of all, I'm going to assume that you know a little bit about random distributions, which relates to statistics and probability. If you don't have a little bit of information about those, I'm going to put some links in the description that will send you to some pages that will give you a little bit of background information on exactly what that means. That's really important to understanding simulation on a computer and really understanding exactly how Arena works. Now, Arena is a fairly archaic program, in my opinion. If you look at the interface, it looks a little retro. This version here, I believe, was actually released in 2012, which was not that long ago. And even so, it still looks, it doesn't quite look modern to me. You might disagree, that's your opinion. But it does have some pretty good functionality. And it's a really good place to start learning how to program simulations on the computer. Alright, so to get started, I'm going to go over a few basic parts of a simulation. So I've got a notepad here where I have typed a few things. First, we're going to look at entities. Entities are an integral part of simulation in most simulation approaches on the computer or a simulation approach anywhere. Yes, it can be done on paper or by other methods, I suppose, but typically computers, obviously. Entities are basically things that move through your system. These can be a lot of different things, like customers. So if you're modeling a simulation that models a store, you have entities coming in that represent customers. These can be parts if you're doing a manufacturing system. Crates, if you're doing some kind of distribution system that handles crates and moves them around different ways. And it can even be calls. Calls are not physical things, but they are digital signals that are sent around, and they can be represented as entities in certain models. Next, you've got resources. Now, basically, entities fight for resources. That is, you've got a certain amount of resources that you can use, and you have entities that need to use those resources. So basically, it's your job to figure out how you're going to allocate those resources to those entities. And these could be things like different types of machines. So that could be robots that work on things. It could be some kind of grinder that grinds up a stone, which could take a varying amount of time. It could be tellers in a bank. It could be cashiers at a store, which would serve customers. It's our entity. And then telephone lines. So for instance, if you've got a call center, you've got multiple telephone lines. Those are resources, and every time there's a call, they're going to seize or use one of these resources that is a telephone line. And then next you've got queues. Queues are very important in simulation. Basically what a queue is it's like a line. When you're standing in line at an amusement park or in the store, you're standing in a queue. And it could just be generally summarized as waiting space. So basically, entities are going to go to queues to wait for resources to become available. They can wait in queues for other reasons too, but we'll get into those in later tutorials. And a couple of things that are really important in simulating, and these ideas can be transferred to other simulation software, but I'm going to be, of course, talking about these in relation to Arena, obviously. First, you've got variables. What variables are? If you've got a little bit of background in programming, you should understand this, no problem. If you don't, I'll try to explain it the best I can. Variables are basically global values. So if you've got a model that you're running, you've got a certain set of variables that are defined within that model. So that means that different things that happen inside that model can change the value of variables. And I've got an example here, and that's work in progress. Work in progress is actually built into Arena, but for explanation purposes, let's say it equals X, okay? Work in progress basically just defines or describes how many entities are in the system. So how many are a work in progress. So, for instance, if an entity enters the system, let's say there's 14 in progress right now. If an entity enters the system, this will go up to 15. If another one comes in, 16. If one exits, it goes to 15. And so on. It'll just change periodically throughout. And, of course, this is done in the background. Obviously not somebody sitting there, or you sitting there typing it. This is done in the background in the code behind Arena. Okay, next you've got attributes. Attributes are really similar to variables, but these are local values. Basically, they are attached to entities. Okay? Basically what that means is if you've got a customer can have a certain set of attributes attached to him. For instance, his name. An attribute, or a name would be an attribute because it wouldn't make sense to have a global value of name. You know, you wouldn't have Tom as a global value. Tom is attached to Tom himself, who is an entity in the system. Another example I've got here, which is, that's really a practical example. Another one here I've got is priority. This is used logically. You can actually take and, like for instance, once a entity enters the system, it may have a priority of 0, meaning that, you know, once it goes into a queue, the machine will just pull it in. But let's say it needs to be reprocessed for some reason. Let's say it moves through a machine and the machine messes up somehow and it needs to be reprocessed. So let's say it sends it back to the system. But let's say that we want the machine to do the ones that need to be reworked first, to get them out of the way first. So once it exits the machine, and once the model decides that it's bad, it'll actually assign a priority of 1. So that number will change, but that's only for that particular entity. Okay, so keep that in mind. Attributes are attached to entities. Just think of it like a name, okay? So each customer has a name, Tom, Jane, whatever. And another example I've put here is how many times it's been processed. So in the same example, if it's got to go back around, then it will have a different amount of times it's been processed. So let's say it's just called Y. So every entity has a value of Y, and it'll start off equal to 0 because it hasn't been processed any. Okay, the first time it moves through the system, or the machine, it goes up to 1. And let's say it gets to the QA guy, and he says, oh, no, it's bad. So he sends it back. It gets processed again. Well, this number goes up to 2. If he sends it back again, it goes to 3, and then 4, and 5, and so on. Now, how this could come in handy is, for one, you could view this later on in your results and draw conclusions from that. But logically, this could help you because let's say if an entity or part, whatever it is, gets quality checked 4 times and it's still bad, once it gets back to that process, it'll check and say, oh, this has been processed 4 times. I don't think we're going to be able to fix this. So you just want to trash it. So you would need that attribute there in order to decide to trash it. Okay, and then the last thing is sets and schedules. I put these here, but I'm actually going to get into those in probably the second tutorial. These are pretty simple things, but they help a lot with logic, and they're going to make things a lot simpler and more realistic as well. which is important when you're writing a simulation, as you want to try to model exactly what's going on in the real world. Alright, so let's get started. I'm going to orient you with Arena just a little bit really quickly. I'm going to try to keep this video as concise as possible. There's a lot of information to cover, and like I said, I'm assuming you know a little bit about probability and statistics. If you don't, I really suggest you go and do some just basic research on that before you start modeling in Arena or any simulation software. Okay, so I've got a standard toolbar here where I can click New, or I can go to File and click New. So I'm going to click New, and you'll notice a blank screen comes up, and then I've got another frame down here. This is where all of our module information values will come up. This is actually where our flowchart is. The flowchart is the logic part of the model. Now, we're going to create a simple model in this tutorial, and then I'm actually going to show how to animate it just a little bit. If you're not interested in the animation part, I'm going to put in the description where it starts, and I'll also tell you when I'm about to start, so you can skip that if you're not interested in the animation. I'll get into some more advanced animation later on. Okay, so here are the different bars I've got set up, and if you want to set it up exactly like mine, I'll right click here, and these are the different bars I have active currently, the ones that are checked. And basically, project bar is this guy over here, the status bar is this guy down here, the animate transfer is this guy here, and standard is the one where we clicked new. Draw is this guy here. This one is animate. This one is view. This one is arrange. And then I've got animate transfer. For now, we're really just going to be sticking to standard and maybe a little bit of draw. I'll show you how to use the draw really quickly. Animate we'll use a little bit. And then view and arrange we may use. Those are pretty important. For now, we're not going to worry about animate transfer. I'm going to leave it there because I've got everything set up how I like it. Okay, so here, if you look at this module, which is the view, I believe. Yeah, that's the view one. You'll see you've got grid here. So if I turn on grid, you'll notice a grid comes up. Alright, and you know what a grid is. Pretty much this is going to help you to control where things go on your flowchart. So notice how it connects to the grid. It actually goes in between them. That's just how I have it set up. And that's going to help you organize things. We'll get to that in just a minute. And then next you have page breaks. This is useful if you want to print out a model. Okay. And notice if I put a module down, it'll put a 1 there. And basically this is page 1. So this shows what's going to print on the first page. So if you're going to print this out, you may want to go with the flow of your model, you know, nice and confined within a page, and try to keep things organized on pages so that way you can print it out in a nice formatted report. Because if you put this here, for instance, it's going to print half and half on the page, and that looks really unprofessional. So that's what that can be used for. But let's turn that off. We're not really worried about that right now. We're definitely not going to be printing this. And you've got some other things here you can check out. Ruler, for instance, shows you your coordinates and will help you position things a little bit. Okay, so one more thing before we get started is navigating the screen. I'm going to put in just a module real quick so you can see how it moves around as I navigate. Basically, you're in 2D, so it's really easy to navigate. Basically, scrolling up and down does exactly what it normally does. It just goes up and down like a page. If I hold shift and scroll, it's going to go left and right, which I believe is what a lot of programs do anyway. And then, of course, as can be expected, hold control and scroll, and you will zoom in. So that's how I navigate. I'm sure there's other ways, but that's the easiest one I found. Okay, let's delete that. We're not worried about it yet. Alright, so I guess it's time to start our model. So for this tutorial, we're just going to create a simple, very simple, probably the simplest model you can create in Arena, that's going to be a machine that processes an arbitrary part. We're going to call our entity a part. So, like I said earlier, back here, we've got entities and all these other things. Entities are what's going to flow through the system. So, what we want to do is we want to start out by having a module that, quote unquote, creates these entities. And basically, this is just representing the entity coming into our system. You don't necessarily create something. This basically just shows it coming into the system. And you'll notice there's a little 0 here. It's nice and squished up. I don't know why they have it formatted like that. But if you want to fix that, just drag that over and it'll look a little better. Or you can double click this and actually go in and change the font. But let's just leave it for now. You can actually delete it too if you don't like it there. But okay, if you click on the Create module that we just created, you'll notice down here that you get a nice little Excel style spreadsheet. You can edit everything to do with this module down here. And this comes in handy later when you've got multiple modules. See, I've got 2 Create modules, and I can take and just edit the different things of each one down here quickly. And also you can take and like copy stuff. So I could just, if I put a 2 here, say, and I also want the value 2 here, I can just highlight it, Control-C, Control-V, it's there. Much faster than using the dialogues, which I'm about to show you the dialogues. So let's delete that second Create module. We don't need it. We can zoom in a little bit. Okay, we're going to edit via dialogue. To do that, double-click your Create module. You'll notice here we've got a name. So let's start with the name. Let's just go forward, take out the 3, and call it part. Create part. So that's going to be the name of this module. And actually, if you go ahead and press OK, you'll see it updates there. Okay. So basically, that's just kind of a bookkeeping thing, so we know what module is what. Which also helps people come in to look at your model later understand what's going on. So double click it again, and let's look at some more values we can edit. Entity type, that's going to be the type of entity that this is going to be spawning. So we're just working with one type of part, and it's just some arbitrary part in some manufacturing system. So let's just call it part. That's the entity type that this is going to be creating. Okay, this box here is time between arrivals, also known as inter-arrival times. So you've got a few different options here. You've got schedule, which I'm going to get into probably in tutorial number 2. You've got constant, you've got expression, and then you've got by default random expo. Expo stands for exponential distribution. Like I said, I'm assuming that you're familiar with that. If you are not, I suggest you go look it up right now if you are interested in continuing in this software. So basically, you've got one value for an exponential, and that's pretty much the mean value. So we're going to do 5 minutes. Now notice our unit is in hours, so we're interested in making it minutes. So change that to minutes. And then entities per arrival, you can make multiple entities arrive at each time it triggers, but we just want one for now. Max arrivals, infinite's fine because the model's going to end at some point, but we don't care about it stopping it at a certain number. And then you've got first creation. This is the amount of time that the first entity comes out. So as soon as we start the system, since it's set to 0.0, one's going to be created. And that's okay. That's what we want for now. And I'm going to show you real quick some of the other options. Constant, that's pretty obvious. If you set it to 5 minutes, that means every 5 minutes it's going to spit one out. So at 0 to create one, 5 minutes to create one, 10 minutes to create one, 15, 20, so on. Really simple there. And then you've got expression. And if you pull this down, you'll notice you get a bunch of different expressions that you can do here. And these are just some preset ones. These are different types of distributions. You've got normal, triangular, uniform, Erlang, beta, gamma, Johnson, so on. So you can put those in, and then once you click on those, you've got in parentheses here the different parameters. And of course, you know, as with normal, you've got a mean, which is where the basically middle is. You can set, some number. I'm just putting in random numbers. And set the standard deviation. And it'll draw inner arrival times based on numbers generated from such a distribution that you've chosen here. But we're going to stick to exponential for now. It's simple, and it's really well suited for inner arrival times, considering there can't be any negative values. That being said, normal is not really a good distribution to use for time. As you know, it can have negative numbers. Okay, so you're pretty much done with that first module. So let's move on to the next module. The next module is called the process module. So drag yourself a process module out onto your space here. And we want the entity to flow from this module to this module. Now notice with each module there is a triangle. That is the out. That's where the entity goes out. And of course create is the start point, so it doesn't have one on this side, but this one has a square on this side. That's the in. So we want this entity to flow out of here and into here. So I connected them. Now, don't want to do that. So how I did that was I went up here to the connect tool and just simply click the first one and click the second one, and it connected them. Simple as that. Alright, so let's take a look at process. I can click on this, and once again I get my nice little spreadsheet down here, and I can change everything I want down here. But for now, let's go into the dialog. So double click it, and once again you've got a name. Let's call this machine works on part. Type standard. Not going to worry about submodel for now. Okay, now we've got the logic, which is this area here. We've got different actions that we can have this process module do. We've got delay, seize delay release, and delay release. It's very important that you understand exactly what each of these does, and I'm going to explain it real quick. So remember back here, we talked about resources, and we talked about having machines. Well, in this one, we're just going to have an arbitrary machine. Okay? So what you're going to do right now, if we just set it to delay, what's going to happen is the entity is going to be created, it's going to flow here, and it's going to move into this process module, and it's just going to be delayed based off what we put down here. And I'll get to how to use this area in just a sec. And then it's just going to move out the other side and to whatever else we put on the other end. If we put seize delay, you'll notice that a list of resources come up. Or, well, a list of where resources will be. And also a priority. Priority can be left medium for now. That's for more advanced stuff. We'll worry about that later. Okay, these are the resources that are associated with this process module. So let's add one. Alright, the type is a resource. Don't worry about sets yet. We'll get there. The type is a resource, and it's just going to be called machine. And the quantity is 1. Now, this is a very important thing to understand with the quantity. Quantity is not actually how many machines are present at this process module. It's how many are required for this process to happen. Okay, so let me make that very clear. This is how many it takes to work on an entity that's incoming, not how many of that resource is present there. Okay, that's something I got really confused on when I first started using this software. So keep that in mind and make sure you understand that. Okay, so right now we've got it set to seize delay. So what's going to happen right now is if I were to click on resource over here, I would see that I now have one resource called machine. This process module went ahead, and as soon as I put the resource here, it just went ahead and defined it for me, making things really easy. Okay, right now it's set to seize delay. So what's going to happen is there's going to be an entity created here. It's going to flow into this process, and then it's going to seize the resource. Basically what that does is it makes the resource become busy. So basically resources are kind of like on and off. You've got busy and not busy. And there's other states as well, but we're not worried about those for this simple model. But some of those are things like failed, like you can have failure mode and idle mode, stuff like that. But basically right now we've got busy and not busy. And next it would then delay. So it would wait a certain amount of time as defined down here, which we'll get to in a minute, and then it would move out. But the problem is it's not set to release the resource. So the resource would stay busy, and entities would come here and they would pile up in our queue, which we'll see in just a minute, and they wouldn't be able to get worked on because the model would think the machine's still busy even if the entity moved on. And the other one that we don't want is delay release. This one would really mess with the system because what would happen is the entity would move in here, wait a certain amount of time, and then try to release a resource that's not even busy. So what we want is seize delay release. And basically what this does is an entity comes in, it seizes the machine, it has a delay which represents the amount of time it takes the machine to work on it, and then it releases the machine, making it become available again, which is exactly what we want for our simple little model here. Okay, next we're going to move on to the delay type, and if you pull this down, you've got a few different options you can do. We're going to stick to triangular for now. A triangular distribution is basically like a normal distribution. It's just in the shape of a triangle. And pretty much it has only three values. A minimum, a median, or a mean, really, which is the most likely value, and a maximum value. And of course, as you move away from the mean, the values become less likely. So this is the peak of the triangle. It's the most likely thing to happen. We want this in minutes. We're basically working in minutes for this entire simulation. And then you've got allocation. We're just going to leave that value added. Basically, that's sort of a bookkeeping thing. That's going to come up in your model results. So don't worry about it for now. All right, I want to put in some numbers down here. Usually these would be from they basically be derived from different data that you've taken in the field, but I'm just going to make up something for now. 3, 5, and 7.5. And report statistics is checked. Basically what that says is it's going to keep up with what's happening with this and give it to you in this report. Alright, hit OK. Everything updates. And now we see we have this little T shape up here. If we click on it, it says machine works on part, which is the name of the module. And it is that because it's basically connected to this module. And it says .q. So this is actually a queue. And we talked about queues earlier. This is the waiting space. So this is basically where entities are going to go. They're going to line up here and wait on this machine to become available if it's busy. Now, you can take and actually move this around, like so, and translate it around, whatever you want to do with it. That'll help us with animation, which we'll get to towards the end of this video. So let's leave it there for now. And notice if you move this module, and it's not wanting to let me, there we go. When you move it around, the queue will follow it. So keep that in mind later. Those are connected. Okay. And finally, these, once they're done being worked on, need somewhere to go. So what we're going to do is we're going to put in a dispose module. And basically what it does is it does exactly what it says. It disposes. It's going to take the part out of the model. So let's put part exits system. We double clicked and got this little dialog here. Record entity statistics, definitely, and hit OK. And once again, we can edit this down here. There's not a lot to edit with this module, obviously. And make sure you connect these up. Okay, and that's pretty much this simple system. So let's give it a save. We're going to put it in ARENA tutorial, and this is going to be example 1. And hit save. Okay, so one thing we want to do, we're almost ready to run this thing. One thing you want to do is you want to go to the entity module real quick, and you'll notice here it's got initial picture. So click that once, and you have a little drop down menu. Now you can't really read them, so we've got plenty of space on our screen. So let's pull it over, and you can see you've got all these different things. Now for these arbitrary parts, let's just put a blue ball. Now if you want to see all these pictures, where you want to go is, I have to click back out here so I can access these. Click on entity right here, and you'll notice over here you've got all these different pictures. And if you hold your mouse over them, I think it'll, well, let's see, click this area, there it is, picture.ball. So that's not actually the blue ball. So let's put that, let's get rid of it. Got everything messed up here. There we go, picture blue ball. So you can see what they look like. And there's people and all these different things. Let's hit cancel. No, I don't want to save it because I messed it all up. Okay, so we've got a blue ball, so that's good. So one more thing we want to do before we run, let's go to run and setup. First, you want to look at your replication parameters and look at the number of replications. For now, we're just going to run one, and then you've got these abilities to initialize between replications. Don't worry about those for now. Start date and time, don't worry about. Warm-up period, don't worry about for now. And then you've got replication length. Right now it's set to infinite, so that means if I were to press play and start this simulation, it would run forever, or until I stopped it, or my computer crashed, or the world ended, whatever happens to stop this model from running. So let's change it. Let's do 500 minutes. So type in 500. Make sure you change your time units to minutes. Hours per day is 24. That's okay for now. And then base time units, that's pretty much the basic time units that everything in your system is done in. Ours is minutes because we use minutes the most. And basically what it does is, once we look at our report, this is what everything is going to be reported in. So if we did days, it wouldn't really make sense because we would have all these really tiny decimals and it'd be really hard to read. So to make things easier on ourselves, you leave it minutes. And then you've got terminating condition. That's going to be better for more complicated models. So hopefully we'll get into that in a later tutorial. The next thing you may want to look at is run speed. This right here is the animation speed factor. It can be controlled with this little slider out here, but usually when you're working with pretty small units, and especially a simple system, even the lowest that this right here will go is still pretty quick. So let's change this to 0.000. Let's do just 0.001. That should be pretty slow. And don't worry about the rest. And then the last thing you really want to look at in this window is project parameters. And we want to give our project a name, and that's simple part machine. That'll work. And then put in an analyst name. My name is Taylor. And this is what objects statistics are collected for. Right now we're collecting for queues, entities, and resources, which we have all of in our model. The rest we do not have or are not really worried about. So let's leave those unchecked for now. Okay, so it looks like everything's set up, so let's give this simulation a run. Now, make sure you save before each run, especially if you're in Windows 8, and we're about to find out if it'll throw this error, but I get this error all the time where it says a server is busy and it can't continue, and you cannot get out of it unless you Control-Alt-Delete and close the program. So let's try to run it, and maybe I'll get that error, and if it happens, I'll show you what it does. But you see here, the model's running. It's still pretty quick. But basically, you can see the parts going in. You see them every once in a while. They'll bunch up here in the queue, and you can't actually see the T while the animation's running. And then they get worked on, and then they move out of the system. This number here is how many have moved into the system. This is how many are currently in this process module. That includes the one being worked on, plus however many are in the queue. And this is how many have exited the system over here. Alright, so the simulation has run to completion, but I'd like to see the results. We're going to click Yes. And this page comes up. And it didn't throw the error for me this time, so that's good, but always save just in case it does, especially if you're running Windows 8, because I haven't seemed to have any problems when I'm using this software on Windows 7, but Windows 8 does it for some reason. Okay, anyway, moving on. You'll come up with this. We've got 3 pages of statistics that this has put out. Now remember, we only ran 1 replication, so these are not 100% accurate. We could run this simulation over and over, and we would get different values each time. So, first you've got the number out. That's how many entities actually made it to the dispose module. That's how many actually got their job completed. And that's usually all that's on the first page. So hit go to the next page, and you can also pull this down and see the different categories. If you scroll down, you see different statistics here. This is value added time. And remember how I talked about value added, it's just a bookkeeping thing. If you notice, for the no value added time, we got 0 because we didn't have any non-value added processes in the model. So if you look here, you've got an average. This is pretty much the average amount of time that it took the part to get through the system. Then you've got a half width. We'll get into that later. It's insufficient. Don't really worry too much about this just yet. I'll get into it in later videos. Then you've got a minimum value. So that's the quickest that a part moved through the system, and that's the longest it took for it to move through the system. Then you've got wait time. This is the average amount of time that any entity or part had to wait in the queue. And then you've got minimum and maximum values. Then you've got transfer time, other time. We didn't have any of that. And then total time. Oops, I told you wrong. Value added time is not the total amount of time. That's the average amount of time that it took the machine to process the part. Total time is how long it was in the system entirely. Then you've got other. You've got the number that came in, and the number out. We saw that on the first page, but it reports it here again. So a few parts actually didn't make it through the system before the simulation ended, but that was to be expected. And then you've got work in progress. That's basically how many entities are in the system. So on average, you have 3.5 parts in the system. Obviously, you can't have 3.5, but it's just to give you a statistical idea and to make conclusions. And then you have the last page. This is things related to the queue, things like how often it took to wait. So things were usually waiting an average of about 14 minutes in this queue. We only had 1 queue. And here's the average number that would be waiting, which was about 2.5. Then you've got resource. You've got instantaneous utilization. This is how much the machine's utilized. Basically, this means that it's 92.98. So we rounded up to about 93%. So the machine was being used about 93% of the time. That's pretty good. The number busy is the same. We only had one. So then the number scheduled, we had one. Don't worry about that. Scheduled utilization is the same because we don't have any schedules set up. And then this is the total amount of times it was seized. Alright, so we'll get in later into how to interpret those results. And to reset this, just hit end. And we can make a lot of powerful deductions from the results of different models. This one's obviously very simple, so we can't really make any conclusions from this. But as your models get closer and closer to the real world, then you can draw conclusions that can help you make decisions and also help you make designs in the real world. Okay, I think I've gone on long enough, so I think I'm actually going to go into the draw and animation portion in the next video. So I think I'm going to make it a separate video, and then we'll move on to a little bit more advanced modeling in yet the next video. So I appreciate you watching. If you are interested in more videos like this, I am putting up tutorial videos as much as I have time for a number of different things, namely development things like software development. I'm getting into that a lot. A lot of engineering tools such as this. I am currently working on getting a degree in systems engineering, and I'm very passionate about the field, and I love it very much. So, you know, I don't want to say I'm an expert, but I don't dilly-dally around in the field, so I've got a little bit of knowledge, and hopefully I can share it with you. So subscribe and keep a lookout for my videos. And if there's any questions you have, feel free to contact me, and I will get back to you as absolutely as soon as I can. So I appreciate you guys watching, and we will see you next time.